Hello student, welcome back to lecture series on M3 subject. Guys, we are here back again with a very fresh unit from our syllabus, which is a numerical method. So we are going to continue our next two unit, numerical method and the numerical method in the differentiation. Okay, yes. So now see that guys, in my today's video I'm going to explain to you all the root finding methods. Okay, so now see that whenever we have like a normal polynomial given, like a linear, like a quadratic, like a cubic, in such a case we can use simply straightforward formula, we can find their root. But whenever we have complex type of the polynomial, okay, complex type of the function or equation, in such a condition guys, it's difficult to find out the root. So after looking all these things, scientists developed or mathematician developed such a numerical method that can be helpful for finding the roots of our given polynomial function. Okay, so now see that within that bisection method is one of it. Okay, so in my today's video I'm going to explain to you all complete bisection method. Okay, but at least you all need to understand why we are learning the bisection method. Okay, yes, actually bisection method we use to find out the roots for our polynomial. Okay, yes, so you will get the question in your question paper, explain bisection method. So you can explain, it is very easy method guys, that we are trying to contract the interval until and unless we do not get the fixed point. Okay, so once we get the fixed point in our interval, then you have to stop the iteration, you will get the required answer. Okay, yes, now let's without further ado, let's get time into our today's lecture. I'm going to explain to you all bisection method first, and then we go for the some of the example. Okay, yes, now see that I will explain in simple language guys. I have interval a and I have interval b. Okay, sorry, I have endpoint a and endpoint b. Okay, and a polynomial given like f of x which is equal to something. Okay, f of x which is equal to 0, this one is a polynomial given. Okay, and we have to find out the x here such that f of x goes to 0. That means x is the solution. X is the solution for f of x is a 0. Okay, so we have to find out the x such that f of x gives us the value 0. That means x is the solution for f of x. So f of x may be quadratic, linear, cubic, fourth power, or maybe higher power. Okay, and one more thing, that if you have given the interval ab, if it is not given, I will tell you a short trick how to find out the interval. Okay, so if interval it is given, so you have to consider one of the random point x1. Okay, so and so consider that x1 is the point between interval ab that can satisfy equation f of x. Okay, f of x which is equal to 0. So using that point x1, we have to contract the interval. So contract the interval such that the interval can give us the next value between here, again the next value between here. At the end point we'll get such a point over here. There we cannot contract that point anymore. So actually that point is the solution for our given f of x is a 0. Okay, so bisection method is actually contraction method that can contract the interval until and unless we do not get the we get the final and a fixed point in our interval. Okay, so this one is a fixed point, that is the required solution for our bisection method. Okay, so for bisection method we need to know 2 to 3 points. Okay, let me explain these 3 points guys. Okay, so for that, this function f of x need to be continuous in this interval. Okay, interval a and b, function f of x need to continuous in this interval. If this interval it is broken, that means it gives us the different intervals, and different intervals are having different solutions. Okay, so I have first point, I do not want any break between a and b. Okay, so f of x is continuous. F of x is a continuous in interval a and b. In interval a and b, whether a and b is open or closed doesn't matter. Make sure that the solution lies between a and b. Okay, so I got the first point. f of x is continuous between interval a and b. Okay, now next point it is simple, guys. When we replace a into the f of x, so we get the f of a. Again, when we replace b into f of x, we get the f of b. Okay, so f of a and f of b, okay, f of a and f of b both need to have different sign, different sign means, for example, let me explain. If f of a bigger than 0, this means f of b smaller than 0 needed. Okay, if f of a is smaller than 0, then we needed f of b bigger than 0. That is like a different sign. Okay, yes, this condition need to hold. So if this condition hold, then we say that between interval a and between interval b, there exists at least one point. There exists at least one point which is the solution for f of x. Which is the solution, okay? Solution. That point gives us the solution for f of x, okay? So that is the method, guys. So see, guys, here this is the condition that we need to remember. Okay, yes. Now see that for finding the approximation, we need to know how the approximation values. Okay, yes. For the interval AB, we write a approximation. Consider that middle point I have x1. Okay, for interval AB, middle point is x1. To perform iteration, we write x1 which is equal to a plus b divided by 2. That means, what is the meaning of x1? This is important, guys. We needed this one for further approximations. Okay, yes. Now see that what is the meaning of x1, a plus b by 2? A plus b by 2 means we want the point which is between interval a and b. Okay, so if you're going to consider as a point a, or if you're going to consider as a point b, that cannot work here. We want the middle point. We do not want the boundary point. So we want the middle point where the solution lies. Okay, that's why I'm adding both of them and dividing by 2. So I will get the approximate middle value. Okay, that is our main target. That's why I consider this formula. Okay, x1 which is equal to a plus b by 2 over here. Okay, yes. So this is our approximations value. Okay, so if you want the second approximation, consider x2 which is equal to next addition of a end point and starting point divided by 2. Okay, yes, that one you will get the solution. Okay, now see that, guys. So after this one, we have some possibilities. Okay, after this form, we have some possibilities that solution can give us the different values. Okay, yes. Now let me explain the possibilities over here. Okay, so what are the possibilities possible? Okay, so first possibility possible here, that if f of x1 is a 0, that means this f of x given. Okay, we want the solution now. If f of x1 is 0, guys, obviously any point gives x1 as a function as a 0, obviously that point x1 is the solution for our given function. This implies x1 is the solution. This point gives the x1 is the solution for f of x. Okay, x1 is the solution for f of x. That means you don't need to find anything, that we are working for the solution now. So we got the solution. Okay, now second condition, if f of x1 bigger than 0. Okay, what happens if f of x1 is the positive? Okay, yes. Now see that if f of x1 is bigger than 0, okay, then what is the possible condition that our solution lies? Okay, the interval a to x1, this is the solution lies between a to x1. Okay, then solution lies a2 x1. Okay, second condition, third condition, if f of x1 smaller than 0, f of x1 is smaller than 0, then solution lies where it lies, x1 to b. Okay, x1 to b. Okay, this is the next condition, guys. Okay, then the solution lies x1 to b. Also, these are the conditions that you need to know. Okay, so these are the three conditions, guys. Remember this one. I'm going to apply for further examples. Okay, now see that, guys. This is the process we have to repeat for the different iterations. As we have iteration second, third, fourth, that process is going to repeat for the similar subsequent iterations. Okay, yes. So as if you get the x1 and b, the interval, add then x1 and b, their addition divided by 2. Okay, you will get the x2. Okay, so how can we find the x2? Consider that this one is the solution. If f of x1 is smaller than 0, then root lies between x1 and b. That means x1 plus b divided by 2, which is the x2. Okay, this one is our next iteration. Okay, again you have to consider these three conditions. Okay, for f of x2 is the first condition, f of x2 is a 0. Second condition, f of x2 is bigger than 0. And third condition, f of x2 is smaller than 0. Okay, these are the three conditions. So using these three conditions, develop new iterations. Okay, yes. This is the bisection method, guys. I'm expecting that you all have understood. Not that difficult. Okay, need to understand the process only. Okay, see that, note it down the point that I mentioned here. Okay, note these formulas and the midpoints, everything. Okay, so I'm gonna continue some of the example, guys, in my next lecture. I hope that you all have understood everything here in my today's lecture. Okay, so that is here for my today's lecture. Let's continue next part. In our next lecture we go for some of the example. So that's it here for my today's lecture, guys. So thank you everyone, thank you for my today's lecture.